So we're going to get started. Thank you for being patient. We noticed that the one app for droidcon had 3:15, so thanks for coming early and hanging out. I'm Matt, and
I'm Sam.
And this is Sam's first conference talk, so yeah, let's go. And so today we're going to talk about keeping color blindness in mind when you are working on your apps, building views, all this sort of fun stuff that we do in our day-to-day. And what we're going to cover, first, understanding color blindness, what it is, how it works, and everything that means.
Challenges faced by visually impaired users, people like me who are a little bit colorblind.
The essential tools for this type of accessibility, and then some strategies to build accessible apps that we can just practice in our day-to-day development. So we'll dive right into what is color blindness, and to understand this, we really have to answer the question and provide a baseline of what is color. And so color is essentially just how our brains interpret different wavelengths of light. And that is specific to each individual person, and we'll go into that a little bit more in a second. But what this means is different contexts impact how we are going to see things on either a screen or just in life. And so there's a well-known optical illusion that calls this out, and I hope this works on these projectors. But the left and the right square are actually the same color, but because of our surrounding context, one might look a little darker and one might look a little lighter. So we actually will connect these. There still might be a gradient, but if we remove the background gradient, they are the same color. So we were a little worried about the projectors, and to call that out, since we're talking about color a lot, they are aware of this in the industry that deals with movies and colors and all this stuff. And so they have these color test cards. And so not only do we perceive colors differently, but we are also presented colors differently. And since projectors are typically bad, they have these so that they can then edit afterwards and bring them up to what they want to see.
Yeah, that was one of our primary concerns for this. We had a lot of colors, and we were worried the projectors would look different if there were multiple. So this was a good example. Briefly, we'll bring this back up. Cool, it's gone. We're not going to go over that.
Yeah, so just a bit of a pop culture reference to when everyone was perceiving things differently and fighting each other over it. If you want to get your phones out, there was recently a website that became semi-popular called Is My Blue Your Blue? And if you scan this QR code or go to this URL, you can take this test right now. It takes like 10 seconds. And what this will do is it'll present you with a green or a blue, and over time determine where your boundary is for those colors and compare them with your neighbor. Everyone might have a slightly different result. Let's see if we can do this real quick.
You want me to answer?
This was a mistake. The mouse is so small. All right, we are gonna.
There you go.
All right, so that's definitely green.
That's green for sure.
All right, what do we think? Is this blue?
Green.
All right.
Green.
Green again?
You're going to listen to me?
It's already happened.
Yeah. Green.
Green again? Oh.
That was blue.
Okay, so then it draws this nice little graph, and hey, we did pretty well. It tells you what your ratio of blue to green is. If you take a look at this without the lines, do you think you would draw the line in the same spot of where you determine what green and blue is? So it's kind of interesting how having the reference determines your answer. Let's see if I can back out of that. Nice. So yeah, again, all to focus on the way we perceive colors is different, the way we understand, the way we name colors is all very different. And so what is color blindness?
So we have two images for you. To me, this is the same image. I do not see any distinctions between any of the three pens in terms of like the pen on the leftmost looks the same in both, the middle, the right. So We're going to briefly talk about what color blindness actually is. I am not a doctor or a scientist, so this will be super basic. Color blindness is largely focused in the retina. Your retina has two types of cells, rods and cones. Rod cells detect light, largely dealing with like low light and night vision. So that affects why you don't really see color when it's dark outside. It's way harder to distinguish stuff like that. And then cone cells detect color. So color blindness happens when your cone cells do one of the following things or some combination of them. They're not there at all, they don't work, or they detect colors different from how you'd normally expect.
Yeah, and so if we do a very rudimentary map of what normal vision is versus color blindness, we can see that normal vision has three distinct hills of wavelengths that are recognized. And there might be a little bit of overlap, but in color blindness, there's a significant amount of overlap. And what this overlap manifests as is an ambiguity in the brain of what color is being seen. And so if you have two colors that are being recognized as one or the other, they could switch, they could just merge, like it can provide a bunch of confusion.
So we also have the types of color blindness specifically. There are two types of red-green, with red and green being the primary color for both of those. They're deuteranopia and protanopia. I'll go over those in a second. There's blue-yellow color blindness, and then there's complete color blindness. So the inner circle is what would be perceived as like normal color vision, and then the outer circle would be what somebody who is affected by this would probably see, or some approximation of. So specifically, you have deuteranomaly, which is red-green color deficiency, primarily green. That's what I have and is what is most common. There's deuteranopia, where you can't perceive green at all. There's protanomaly, which is red-green color deficient, but you're red deficient instead. Protanopia, where you can't perceive red. Tridanomaly, which is blue-yellow, primarily blue. And then tritanopia, where you can't perceive blue. This shocks some people. About 8% of the population in total, largely men, are affected by color blindness. It's 1 in 12 and then 1 in 200 women. Here are the stats for you. For the most part, most people are affected by deuteranomaly. Next common would be protanomaly. Everything else is not insignificant, but is largely rarer than that, so you're unlikely to run into it.
Yeah, so taking this all into account, there is also the potential for all of us to be impacted by some form of color blindness, and those we just decided to call temporary color blindness. And so what do we mean by that? Well, we'll bring up the projectors again. Again, they might not have the best color correction that they are calibrated for. They might not show everything as it is designed to be seen. There are Android features that do this. One, namely, is bedtime mode will make your whole device grayscale. If you want to take a glance at something or read a message, you want to make sure that your users are still able to access that information. There's a big movement for blue light filters in the last few years for people who want to preserve their bedtime or afternoon computer use. And so this could shift a user's entire screen more orange, and so you want to make sure that things are still going to be usable by them. But this is a software solution. There could also be more mechanical solutions, such as tinted glasses, whether they're sunglasses or yellow glasses for driving, or again, blue light filters, stuff like that. So yeah, what's it like to live with color blindness, Sam?
It's a real pain, but only sometimes. So just a brief anecdote. My freshman year of college, I was in a chemistry class, and me and my buddy were partners for a lab, and the first lab that we had to do was to look through a microscope and identify different wavelengths of light, which is color. In other words, we could not see a single thing. We couldn't do the lab, so the girl next to us kindly did the whole thing for us. I've known for a long time, I guess that was a bad idea, but we did do that anyway. That was fortunately the only color-based portion of that. But it's something you run into that maybe you don't really think about too much, but I unfortunately have to deal with. Another thing more common that you might know is Ishihara plates. These are basically just a bunch of colored dots, and in theory, I wouldn't know, there's supposed to be either a number or a letter or something inside. So I designed this slide. Matt told me later that 2 of those are duplicated, so that was fun. I didn't know how the projector would be set up, so we did highlight a specific example. So if you can see a number in there, that's normal. If you can't, I might have some bad news for you. I got tested when I was a kid. They did it in elementary school. I was about 4, and I've known ever since. Brief phone call with my mom, and my mom went, "Yup, we know." And if you're a movie fan, you might have run into this at some point. This is specifically taken from the first Kingsman movie. This is the production studio Marv. Of course, again, I can't really see that, but you might be able to. They did rebrand it, however. So, just a few examples of stuff that you might not really think about too much, but does affect people who have color blindness.
Yeah, so getting into understanding some visual accessibility challenges. This is what we're going to coin as colorblind people problems. So this is a graph that is, a bit on the nose, colored a certain way, but purposefully misrepresented. Just to emphasize a point, we do have a more realistic example of a budgeting app with a pie chart. So on the left here, we see various different colors correlated to the legend. On the right-hand side, this is what someone with deuteranopia would be seeing. It's very hard to determine what is a significant part of portions of this graph. And this can be resolved through a better designed graph. So if we take a second to look at what that could look like, we'll go through a real example. This one has separations to call out each section. It has labels to further signify. And in addition, it's just an overall more clear graph, even on the left-hand side. It's easier to understand. You can more easily glance the information. So Sam looked over to me during the keynote and pointed out this slide.
You might remember this graph from Kevin's keynote speech, yeah. And
Yeah.
I went, yeah, I can't read that. So he kindly let us use it.
Yeah, thanks,
for
Kevin.
that. And we recreated it here so we could show some things you can do to kind of improve, even on a simple scale.
Yeah, so namely, using a colorblind friendly palette, purples and yellows are typically friendly across all versions of color blindness. And so we changed our darker color to purple here, and then we'll change our lighter color to yellow. This is already a big improvement overall, but since we're also going to be putting this on a projector, we'll just make those lines a little thicker so that everyone can see them wherever they are. And then add a pattern. Patterns are really powerful for colorblindness accessibility because it gives the brain another way to correlate a section of either information or UI or something with like that color versus the color itself. And then add those labels so that we have more glanceable information to increase the overall clarity and comprehension of the graph. And so now, if we remove all color, we can still totally read this graph.
And this is, a bit of an oversimplification, but there are many elements you can borrow from this if you were to actually apply it to something that you are designing. Labels are pretty universally useful. Separation, patterns, always recognizable, stuff like that.
So, what can Android do out of the box? You get a phone and you want to see what color blind accessibility features there are. There is a color correction setting. It looks something like this. There are 4 different options for red-green, both types of red-green, blue-yellow, and then grayscale. What this does is it will put a filter over the screen so that it emulates the sort of color blindness. This is, from our experience in research and firsthand anecdotes, not the best solution for someone who deals with color blindness on the day-to-day because it doesn't really extract the colors. It more just muddies what is already there. And you can't really screenshot it, so we have this slide as well to show some images. Thanks Michelle Ramon, who's also here. You should go say hi for this. And you can kind of see on the right-hand side is the most intense version of this, where it blends so you see very much yellows and blues. On the left is the separation of colors. So basically it's emulating but not solving the problem from what we've seen. Do you want to?
Yeah, So this is introduced for Android 15 or 16, generally speaking. It might be impactful, it might not. In my opinion, the feature itself is not all that impactful. I built up a general mental model for things that I can see and things that I can't. So turning something like this on actually radically changes all of that, and I no longer know what things look like anymore.
Yeah, so if we go back to the Is My Blue example, where we have the green, blue, and then there's the turquoise in the middle, what we have learned are those colors, are what we recognize those colors as. If we are now changing those colors fundamentally, you can then lose what your reference point is in your own head to recognize and name a color. And I recommend trying it out. Go back to that website, turn on one of these settings, and give it another shot. But Reddit, we went around r /colorblind a bit, saw some posts about this, and the synopsis seems that people would rather just suffer in the familiar way, the way that they know and deal with in their day-to-day, rather than have special cases. And there's also a social aspect of this, especially in younger people who have color blindness. They share a lot of things with phones with their friends, and if your phone has this filter on it and looks different, you are then perceived as different, and a lot of that societal pressure is very negative, and they don't want to deal with that.
Another example is high contrast text, which is actually particularly useful. This is the app TickTick. I don't know if you're familiar, but it's just a simple to-do app. On the right, you can see I have the feature off. The text just says at 9 a.m. pack, and you have some coloring based on your material you set up. So the main thing to notice here is that on the left, when you turn the feature on, in the 9 a.m. pack row, there is syntax highlighting when you specify the time. High contrast text kind of breaks that a little bit. In my opinion, that's fine. I think that generally knowing how the app works and having the ability to read that text, which depending on the color palette, material you chose or you've chosen for yourself, could make at 9 a.m. particularly difficult to read. The same goes for the date selection row and the category of the task you're placing it in. So you could see it says tomorrow, 9 a.m. Vastly more readable on the left, where there's just white and black and no colors over anything, and then inbox is also more legible. My experience was similar using high contrast text for a bunch of apps. There are plenty of things that you kind of lose the color edge to, things that we've probably spent time designing and working on, but definitely makes it more usable and more readable across the board for accessibility reasons.
So that brings us to another option that we found in the developer settings. So this might not be available to all the users who don't want to necessarily enable or dig into this, but there is a contrast intensity that can be selected. There's 3 options for standard, medium, and high, and what this will do is actually change the material you palette to choose a higher contrast color. And so if we take a look at Gmail, we can see that the compose button and then the bottom navigation buttons have a punchier contrast versus the standard in medium and high. And so the fact that it actually changes the palette can be more impactful than something like the color correction, because it increases the contrast, so more color, more distance, so users will be more easily able to determine what they're trying to do. And the keyboard's another good example of this. Again, happy to talk about where these are afterwards if you need help finding something like this. But this is all what Android can do. This is all like after the fact, once the user's already installing the app. Before we get to that, we can talk about what we can do as developers to keep some of these things in mind in our day-to-day practices. And so that typically when we think about Android accessibility and vision accessibility, we immediately go to TalkBack. And for colorblind users who can still see, TalkBack is not a good solution for them. So it's something that is kind of the basis of our talk, and why we started getting into this is because vision accessibility is not just about TalkBack. You wouldn't want to use TalkBack yourself if you can see, because it does change your muscle memories and your patterns of using a device, and we shouldn't expect other people to do that just to access our apps.
Something cool that we found Google has is called Accessibility Scanner. It's just an app you can download from the Play Store, and what you can do is take a recording or a screenshot of an app. For these examples, I used X and Goodreads, X on the left, Goodreads on the right, and you can analyze what it records, and it will give you output for certain things. I specifically chose the two examples related to what we were talking about, image contrast and text contrast. It did take me a while, actually. I had to go through like 6 apps to find text contrast as a problem.
Which is a good sign.
Yeah, it's a good thing. So we're doing better on that front than images, which are significantly harder. Actually, yeah, good example, I guess. I can barely see the 3 dots on the projector, but I do know that they're supposed to be there. There are a lot of other useful things it provides: content description warnings, text that's technically invisible, some layouts overlapping on each other that might affect talkback users. But the general idea is accessibility scanner can be a good starting place. And even if you have high contrast intensity, like we were just talking about, or other like high contrast text enabled, accessibility scanner still works and will still flag things. So it is pretty much universally usable, even if you have other settings on, like color correction and things that you're messing with.
Android Studio has a layout validation setting, so this will give you a grid of the different types of color blindness for any of your UIs or Jetpack Compose previews, and show you what they look like if you were a user subjected to some kind of color blindness. And here's a little zoom in for a different option, just so it was visible on the projectors. But again, please play with this. It's very cool. Color correction that we talked about does exactly the same thing, where when you enable these settings, it makes it look like this, which is why we don't know that this is necessarily a user tool versus a developer tool. And we think that there are other strategies that could be done to shift these patterns so that there is less of an overlap of the ambiguous wavelengths for colorblind users, and that would be more of a solution for anyone who wants to use that. So we're hoping that we can see if Google could change this, but I don't know. I don't know how much traction this feature gets. But we do have some colorblind best practices. One app that does this really, really well is Trello. And so here is just a column in Trello with some cards. These cards have colors, and there's a concept of a semantic color, and that means color that carries meaning. So if you think something like a stoplight, red is stop, green is go, these could be colored for priority. And so a user would want to know what is the highest priority ticket here. These are ambiguous colors, so even though there are duplicate colors here, they could be difficult to discern. There's a colorblind friendly mode in settings. And so what this does is when you have these cards, it will then add a unique pattern based on the color. And so now, regardless of if we can see or discern what these colors are, we can group them by this pattern to know which ones should be a certain priority or which ones should be grouped together. And like we talked about with the graphs, using patterns, again, super helpful for this sort of information.
Another one, obviously, using inclusive color palettes. There are a bunch of design tools, like Material itself has a generate unaccessible color palette. And most of those are actually accessible by default. They follow a set of standard guidelines, WCAG, which are just accessibility standards and guidelines for contrast and color, among many, many other things. So this, obviously, inclusive color palette. We had another example, pretty good. All of the individual bars, basically, are visible to somebody like me and perhaps people with other problems. And they're at least visually distinct enough in this example, too, that I can actually tell where they start and end, which is typically another problem.
Yeah. So again, purples and yellows, typically pretty safe. So proper contrast also matters. This will get called out by Accessibility Scanner. It's super fun to play with. It's very easy. You just download it and run it on your phone. You can run it on any app, and it's great. Things like this contrast on the right are not, I don't see this at all on the projector, but just something to be aware of. And then I mentioned semantic colors a minute ago. We have, through society, learned that certain colors mean certain things. It can be helpful to label these things or add icons to signify what these are in case the colors are ambiguous or next to other colors that might provide some sort of misconfigured information. So key takeaways, color blindness is very common and depending on the situation can apply to everybody.
One of the most important things is to be sure to test your app and everything you make with color blindness in mind. Not strictly necessary, but there are plenty of tools to help you with accessibility in general, and color blindness falls under that umbrella. Accessibility scanner, very powerful, still highly recommend it. Color correction, if you want to kind of see what it would look like. The layout validation as well, if you wanted to see that from your Android Studio instead.
And then when color is critical, like those semantic colors, use labels, icons, and patterns to add a bit of extra contextual information so that users can more easily navigate your app. And that's it for us. So thanks for coming. And